Hello, good morning, good afternoon. Welcome to our live webinar for ECM rifling here at EMAG ECM in Holbach. My name is Ingo Pavlak. I'm the sales director for ECM. With me, I have Audrey from the technical sales. Just a comment right away from the beginning. You have the option during the webinar to use the tab option where you can ask questions during the webinar. And after the official part from the presentation, you have the chance and, or we have the opportunity to answer your questions as most as possible. The other ones, we will follow up the questions that we cannot answer and will be answered afterwards. Okay, Audrey, let's
start. How does ECM works? ECM means electrochemical machining. It is a non-contact machining process that dissolves metal. An electrochemical reaction is created between a metal part, the anode, in this case a barrel, and a tool, the cathode. For this, we need a conductive solution electrolyte who is injected between the tool and workpieces with a minimal gap and a pulse current. We need around 85 millimeters per minute to achieve a roughness from 0.1. But this always depends on the material, of course.
Okay, then hopping into the rifling technology in general. So what we see here, we have all kinds of different profiles that we have shown in the lower left area. So a 9mm cathode is not always the same. It can have different shapes. So 9mm is just the size of the caliber, but the profile can look completely different. So we have partly we have 4 lancing grooves. We have 6 lancing grooves. We have most complex geometries like polygon, hexagon, or octagonal, and also the multiradial. Each of these different calibers can be selected by just taking the relevant cathode, and the exchange for one station takes approximately 3 minutes to change from a different profile. So from 4 to land to grooves to 6, just to exchange the cathode takes you approximately 3 minutes. So when we talk about the accuracy from the process, so usually the land diameter will be done by a honing process, or can be done with a polishing process where we open the diameter to the final land diameter by 0.1 millimeter in diameter. For the groove tolerances we can achieve, we are talking about 50 microns tolerance. The land can be done with approximately 5 microns. Groove depth usually with a small caliber up to caliber 50, we have 0.2 millimeter with a tolerance in width of approximately 50 microns. That's given by the cathode and the process parameters. Progressive rifling is also possible, but here we reduce the active area of the cathode and we need to reduce a little bit the speed of the Z-axis. Surface quality, as Audrey already mentioned, if we have the best possible material, it's heavily relies on the material, we can achieve RA up to 0.1. On this slide, we see the different technologies that are achievable. So we spoke already about the polishing process. Here we have all around the active area where we open the diameter to the final land diameter or tolerance of. Here we remove approximately 0.1 millimeter to achieve that, and afterwards we go then for the rifling process. So it's divided in polishing, and then afterwards it's rifling, the standard rifling. Rifling has a cathode where we have the different profiles that we have seen before, but also the special calibers with polygon, multiradial that we see on the lowest picture can be done. And all of them can be done either with the choking option to change the diameter to make it closer at the muzzle end. So that's something you can just program. It's very easy. Comparison of the rifling technologies. Of course, let's start with ECM rifling. The main advantages that you have, that you can process soft and hard material at the same speed as you can have hardened material. It makes no difference. So we're talking about a standard rifling speed of approximately 85 millimeters per minute, and it does not matter if it's hardened or not. So in addition, since the process is not touching the part, we mechanically don't stress the barrel. We only clamp it, and that's the only force we put on the barrel. And the clamping is very soft, so we don't bend the barrel. In addition, there's no heat in the process, so it's a cool process, and we don't have any material changes during the process. Another thing, our machines can be adapted to the most common geometries, so we can work with standard tubes, as we also have our sample part later on. Also, we can process almost or completely finished barrels with the outer geometry. So, since we don't have any stress on the part and the part is pre-straightened already and we machine it, there is no straightening afterwards necessary. Then we look at the hammer forge and the button broaching. Hammer forge, only a couple of materials can be processed there, and very thin or very thick barrels, it's a problem to machine them. Afterwards, you need to straighten the part because the mechanical forces into the part, so the barrel intends then to bend afterwards. So you need to re-straighten it. With the button broaching, one major thing is that you have sharp edges from the land and groove transition, which gives you then forces if you add pressure, and could give you a problem in terms of wear. Only a couple of materials can be machined in that, so not all. We can process aluminium, steel, stainless steel, titanium as well. So this, for example, is a titanium part. And thick barrels are also hard to produce. Of course, also here in this process, you don't need a straightening afterwards. And if you compare the profiles, going back to the ECM rifling, you see we have a smooth transition between land and groove profile, which gives you a major advantage in the stress of the barrel during the shooting. Okay.
Then here is an example of the time required to machining a long barrel of 560 millimeter with a feed rate from 85 millimeter per minute. For this barrel, the process time will be 400 seconds. For the loading and the unloading, around 120 seconds. For the cycle times per parts is 65 seconds with an 8-fold machine. This means that you can work 55 barrels per hour. For the next example, then a smaller, for the pistol, for example, with a length from 109 millimeter, the feed rate will be also the same, 85 millimeter per minute, and the process time will be 77 seconds. The cycle time for this part will be 21 seconds per part with an 8-fold machine and 84 seconds for a 2-fold machine. Here you have the two types of PE machine rifling that we propose by EMAG. The 8-fold for barrel length from 320 millimeter to 820 millimeter, or 70 millimeter to 680 millimeter. For the 2-fold, the barrel length can be 50 millimeter to 1 meter.
Okay, then since it's a live demonstration, we also have a live demonstration directly at the machine. Right next to us, we have a 2-fold station machine. We have prepared barrel. It's a 7.62 millimeter barrel. So the outside geometry only machined in the center face and the other center face on the opposite side. So when we go through with the endoscope, you see nothing machined, just honed and finished. No profile inside. So we go all the way through. And now we're out. So the barrels is on the outside, not machined at all. We just to make sure that we have a good contact here. The machine is set up with one station only. This is a 2-fold station, but you can run also one. Same on the 8-fold, you can run it with 4, 2, 1, whatever you decide. So we need to insert the barrel to make sure that it's tightly in the lower part of the tooling. We clip it for orientation, and the rest will be done by the machine. So we just start and the machine starts. Here we have the top part that will go down, seal off the top part of the barrel, and then the Z-axis with the cathode goes into position and starts the process. So we just start the process. It's initiating now. Closing the tooling. Anodic contacts closing. Electrolyte starts to flush to the relevant parameters we set up for this kind of barrel. And the main parameters can be seen on the display, the HMI, where we see all the electrical and electrolyte parameters. And just simply switching over to the tank, we see all the volumes in the clean tank, in the dirt tank, what's the situation there, and the main parameters for the electrolyte. Okay, since we can look into the barrel, we prepared a video that we can start. So here we see standard tube barrel. That's assume it's a 7.62, but it doesn't matter, it's the same thing. Here we have the setup for 8-fold in an 8-fold machine. But from the concept and all the actions of the machine, it's similar. So all parameters, or the parameter setting is set for all 8 cathode. We cannot run a 50 cal on the right side and 5.56 on the left side. That's not possible. So all the barrels need to have the same parameters. So here we see a cathode. In the starting position, we make an anodic contact, and then we are polishing all the way through. Now we have been switching in the barrel to a rifling cathode, but in principle it's the same. We drive with the Z-axis and do the rotation when we go through, of course as well with the polygon. This picture we have also seen before. We spoke about the polishing, rifling and polygon, as well as different twist rates where we come later on. Choking. Big benefit, not all of our customers use them, but the machine is capable to do so. So it's up to you what you decide. You can have the relevant settings in a matter of minutes just by changing the voltage during the run. So it will be then a recipe that you have for each of your different barrels. You change the cathodes, and then you select the relevant program, select 1 station up to 8 stations or whatever you want, and then hit the start button. So the changeover time from one caliber to another one is approximately maximum 10 minutes, something like that. And then you're good to go for the next caliber. Good, then let's talk a little bit about the machine and its key components at the machine. So electrochemical machine means we need electrical power, of course. So position number 1, it's a control cabinet, also housing also generator technology, posting technology. Number 4, it's a Siemens touch display. You have seen it live already here when we selected between the different program or the views. Waste air purification. Some process needed, some not. The rifling process, as tight as it is here, as we have seen it, you see no splashing, there's no mist or something. So, but in case we have a different machining operation, must not be specifically a rifling application, but then you have this system as well in place. And number 3 is actually the parts, the inside that we put into this kind of machine. So the machine is actually always the same. We just change the insert from 8-fold or 2-fold, short and long barrel. So this is a more detailed view, just where the job is done for the rifling inside of the working cell, where you add your parts. So one main benefit, of course, is the mineraled frame, which makes the machine very sturdy, tight tolerances, temperature resistant. So this is one of the main advantages with our machines that we have here. And we make them by ourselves in our manufacturing plant themselves. So cathode, of course, this is a hard piece of the ECM process, because the cathode is the main component, as in a milling machine, it's a milling tool, it's a cutting tool. For us, it's a cathode. The workpiece, of course, needs to be inserted. Here we have an example in position number 3 of a pistol, similar like that. So a short barrel, 9mm in this case here. The NC axis that drives the cathode into Z direction through the part. The lifting axis, number 5, this is actually the whole unit that moves. C axis we need for the twist rate, so the twist in the program needs to be adapted to the angle of the cathode. So we can freely adjust this here in the parameter settings for constant twist, if we have the option constant twist. There are different twist modes possible, like progressive rifling, gain twist, whatever, but this is a different topic here. And last but not least, the flow box with the sealing that makes sure that we have a good control over the electrolyte. Since this is a main parameter, we want to make sure that we have all the relevant data for each station on our display and can control them. In case there's a deviation, we got the error message from the machine that we may have a problem in this area. Here now the CAD view of this unit to give you maybe a better idea. We have on the left side, we have the NC axis with a ball screw drive, 25mm, that moves the whole unit. We have the liner guide, 25mm pneumatic clamping, which seals the part in between. That's the sealing to make sure we have the electrolyte under control. The sealing with the rubber below to make sure that the salt crystals are not on our drives and the guiding areas. With the base console, we screw it to the base of the machine so that the whole unit that we put into is securely inside of the machine frame and properly connected. Cathode holder on the top. The cathode holder is necessary since we need to get the power from the generator via the C-axis to the rotating units through the cathode rod to the cathode. So lifting unit we discussed already, and the polymer concrete base body. Then the machine just not exists from the working cell, as we have seen in the live unit. We have the electrolyte management system as well as part of the machine, and this unit is actually necessary to control our electrolyte. This is water with salt, it's nitrogen nitrate. So I see the process is finished, so roughly 6 minutes, so we interrupt here. So the machine process has been stopped, the Z-axis go into the homing position now, opening up the part and opening the anodic contacts. So we give it a second, and that most of the drips are falling down. So this is not a manufacturing sequence what we do, it's just for the live demo, but I rinse now with clear water to make sure that most of the hype. So we take out the barrel now, and then we blow it out with compressed air, that we can have an inspection with our endoscope. So, same barrel. This is now, make it light. So you see the shape. I just twist it now, and now I'm going all in without rotating. So you see the twist rate, the lands and grooves, until the end. So nicely machined in all areas. We got no error message from the machine, so all the relevant parameters has been correctly machined. We have no deviation, so we have a good barrel here. So you can assume now in the same cycle time you can also run 8 parts. The only difference is the loading time to get the parts out and in, but the cycle time is the same, so you can then maximum would be 8 barrels in the same cycle time. Good, then coming back to our machine in principle, we've stopped at the EMS. EMS is the electrolyte management system. As mentioned, the material that you have usually have chips in your milling process and so on, we create hydroxide. Hydroxide is a material that is actually some kind of sludge that we need to get into the dirt tank. The dirt tank then filters the material or the electrolyte and takes out the sludge in the microfiltration. The microfiltration then has a backwash function that if it's full with the sludge, it will transfer it to the chamber filter press that get rid of the main material. It's a manual chamber filter press, so the machine detects the pressure and flow, and if we reach a specific level, the operator gets a signal that he needs to open and clean the chamber filter press. The EMS is as well relevant to keep our electrolyte in good condition with filtration. Of course, that's one of the main things, that we have always clean electrolyte, but we also control, of course, the temperature. So it will be measured and controlled by heating elements or heat exchangers to bring it to 25 degrees and keep it there in this temperature. Because the deviation in the temperature will also have changes in the conductivity. On the other hand, we also measure in a redundant system the pH level and adjust it to pH neutral. So it's no problem for the hands or so. If you touch the part, it's pH neutral, the electrolyte. So since we from EMAG, we not build only rifling machines, as you may know or hopefully know. Our machines are set for all industries. So our machines have all the process control that the modern or the actual industry requires, which means we have exact data from each barrel that we manufacture, which means if you have a system in place where you keep track on specific barrels with serial numbers and so on, you have dedicated parameters that you can save and store for this one. So main parameters for us in the ECM process is the current and the voltage during the process for each single barrel. The electrolyte pressure and flow as also an additional main parameter. Temperature will be managed by the machine by itself. And of course, ECM machines all have not the option, it's built inside, short circuit detection and current monitoring. If we are processing barrels with chromium levels above 2%, we also offer the option to have a chromium reduction system inside of the machine that automatically reduces the chromium, that it can be filtered out, and we don't have a problem there.
Then to resume, the key and the advantage of the ECM rifling technology. It is a non-contact machining. This means without thermal or mechanic influence. It's burr-free and no deburring is required due to the process property. It's a silent process, and you will have less tool wear, of course. It is a modular machine concept because you can machine between 1 and 8 barrels at the same time and with different geometry. EMAG has 20 years of experience in the ECM. We have our development, design, manufacturing, and assembly. We have here in Heubar our application center to do your test. So then the webinar presentation is coming to the end. We will be able to start with a question if you have it. So then first, sorry.
Coming back to one of my last pages here, sorry for hopping in again, but we have seen now only our machine, right? So it's only ECM by itself, but nevertheless, we as EMAG ECM, we see us as a partner because we have sold over 20 machines. We gained a lot of experience with our customer and future customers that we're currently in discussion. And for us, we see each other as a partner to give help also for customers that are new in the business of barrel manufacturing, as well to the other processes in automotive and avionics as well. So when we talk about ECM rifling, we also need to talk about the pre-process. Pre-process means the parts that we present to ECM, they need to be free of loose burrs. They need to be free of oil because the oil is an insulator, and we then have a bad contact, and if we have oil inside of the barrel, it can give you a bad surface quality. So pre-washing is really necessary that we can offer as well and be a partner for the selection of the system, as well as the post-cleaning. Post-cleaning means we need to rinse off the water, the electrolytes, the salt water, and afterwards we do a cleaning, mostly in ultrasonic tanks with dedicated nozzles that go into the barrel, and afterwards, of course, the conserving, depending on what the follow-up processes are. At EMAG, we also looking for options, or we offer the options to help also with the other processes like turning machines. EMAG is offering turning machines also for these kind of barrels, as well as laser hardening, laser welding, or maybe as well laser signing. So the options are multiple. If you have questions about your process line, come to us. We will assist you in that, as well as if you have the idea of planning to integrate in automation. We have already 2 machines, 8-volt machines in Europe that are fully automated, and the machine is already prepared for all of that options, so you can hook up your system. And since we have also part sensors, we can also, that's one of the major parts if you want to do automation, that you have that option already, and it's already built in. So, okay.
So then let's start with the question, sorry.
All right.
Then how many parts can we machining with the same tooling?
You mean the cathode most likely. So actually what we have discussed, the cathode is a cutting tool for our process. It's not a cutting tool, but nevertheless it has limited wear. Since we're not touching or overstressing by heat or mechanics, the wear is only coming from the surface quality of the barrel. Sharp burrs at the entrance of the barrel can reduce the lifetime. We have made excessive tests with our customers presented here in our plant. They brought 300 barrels. Each of them has been pre-measured and post-measured, and we checked the quality of the cathodes during the run of 300 parts, and we had no wear at all. Also, the quality of the barrel profile was still okay. We stopped the official test because time was running out, but this cathode has been running up to 400, 500 barrels without any problems. But it strongly relies on the incoming quality of the barrel.
Okay. Is it possible to do some tests?
Oh yes, please. Yes, of course. Here at EMAG ECM in Heubach, we have quite a big application center with all kinds of machines, not only rifling, but all the other ECM and PECM applications. And of course, we have a selection of the standard calibers. Of course, we have not all profiles, maybe for 9mm, but I would say 85% of the 5.56, 7.62, and 9mm we have already in place. We just need to have the information about the profiles that you want to have regarding the twist rate, the width of the grooves, the number of grooves, and the caliber. And based out of that, we can check our cathode inventory, and then we need to know how long the barrel is, what is the outside dimensions, what is the diameters, that we can have the proper sealing. And then we can do the tests here in Germany and shortly as well in the US, where we are intending to send a machine in the near future, or near future, let's say 2 months concrete.
Perfect. Is it DC current or pulse?
The machine can do both. We, for best surface qualities, we do the pulsing mode. It was also on one of the pages that Audrey has shown right at the beginning. So we work with pulsing, yes.
Okay. Then, after the ECM operation, no further removal of any oxidation needed. No internal brushing needed?
So in mass production, if the process is set up correctly, this is where we come in with our experience. Like I said, the machine by itself does the process and does the machining, but the post-process also needs to be specific for ECM and rifling. So most of our customers, they have a clear water tank afterwards, so they put the barrels out like I did. I just made my version just with a spray can. But most of the customers have a tank with just clear water after next to it. Then it goes into an ultrasonic tank where we do the outside, but ultrasonic will not go inside of the barrel on long barrels. So a dedicated nozzle that goes into position does the job pretty well. So this is actually the standard how to do it.
Okay, perfect. Then which material is possible for machining?
So at the end, each material that is electric conductive can be machined. There are some very few specific materials that are hard to machine, but we have, for example, we have a titanium part here. So the speed of the titanium or processing a titanium barrel is similar to a standard steel. Inconel can be done, stainless steel barrels. So far we have not found any barrel materials that we could not machine.
Looks good. What size of caliber can be machining?
So with this kind of machines that we have here, so we call it small size, up to standard would be 50 cal, but 20 millimeter could also be done. We have done parts, also this part has been made on a machine like that, so a similar machine. And we made barrels up to 35 millimeter, shorter versions. For grenade launchers, 45, 40 millimeter is also possible.
Okay.
But worst case would be that you have to disconnect one side because the power requirement maybe just be good enough for one barrel.
Okay. Then, what about the chamber?
Yeah, so different customers, different production sequence. Some customers, most of the customers do the straight barrel, do the rifling, and then after all the other process, so as the last process after OD profiling, they do the chamber as the last operation. In case we have also customers that had pistol barrels with 9 millimeter where the chamber was already inside, so that we don't damage it with our cathode when we go into the barrel. we had some plastic plugs that we put in to cover that area.
Okay. Then, do the filter need to be changed?
No, definitely no. We have customers that run their machines 10, 15 years without changing anything on the filtration. It's a self-cleaning system, the microfiltration, so there's also limited maintenance work. If all the process parameters are in the limits of the machine, the filtration works forever. The only thing that you need to do manually is open the chamber filter press from time to time, but the machine will tell you when. And then you need to just wiggle a little bit, and then the dirt falls down into the basket or the cart, and you can take it out then. And also these chamber filter press they are rock solid. They're working since principle is older than, I don't know, 80 years or so, and they don't break. So worst case would be that the filter clothes may be damaged because somebody's washing them with high pressure.
Okay.
But that's it.
Then, do you have a factory in the US or around the world?
Yeah. So one of the main benefits that we hear also from the market why they're working with us as a partner is we have a very strong footprint globally. Of course, in Germany, here ECM, rifling headquarter, I would say, here in Heubach. But nevertheless, we have a very big service team, globally spread. We have plants in China. We have subsidiaries in the US. The US will be the next subsidiaries that will be equipped with a rifling machine, also then capable to make POCs directly, even within shorter period. Also based on the problems with some ITER requirements that we need to follow up, so it will make our and the life of our customers way easier. But one of the main points is service as well, because we cannot wait to have 3 days to have an expert somewhere, say, flying around the globe. We need the team locally stationed, as it is in Asia or in the US, and
Yes.
this is definitely what we can have and offer.
Okay. Then, can harness part be machining?
Yeah, we answered that already during the introduction presentation. Yeah, hard or soft does not matter, and also the speed where we machine from polishing or from most likely not polished, because then you remove the hardness. But rifling can be done in the same speed. Does not matter for us.
Then, if the external geometry is finished, can we do the rifling after?
Yeah. On one of our pages, you see the advantages from ECM machined barrels compared to the other processes. And what we see, or one of the main benefits, is that we don't have any forces going to the part, neither from mechanic pressure. We don't have cutting forces inside of the barrel. We have no thermal stress. We don't generate any heat here. And based out of that, we don't got a movement of the barrel. So a completely finished outside geometries as we have here, even thinner, like air guns, caliber 4.5 millimeter with a very fine tube. They will be machined without changing anything in straightness. So definitely yes, even with the threads here at the chamber side or the muzzle side.
Okay. Then we are coming to the end of this webinar. Now, for all other questions, please feel free to contact us. Thank you for participation in this webinar.
Last word from my side. So thank you everybody for joining the webinar. It was a pleasure having you on board. In 2 weeks, if you are around, we have the Enforce Tech 23rd to 25, where Audrey and myself will be attending, as well as the EVA that is directly afterwards from the 26th to the 1st of March. That's the EVA in Nuremberg. So if you are around, if you have questions, maybe you have already detailed questions that goes beyond the option of the tab to ask for these, please pass by, join us, Audrey and me and our other colleagues that are at the booth. We also have a machine with us that you can see there, And we're looking forward to see you at the show or over the communication by mail or here. So you get my contacts and Audrey's. So please ask or come by. So thank you for joining,
Thank
and
you.
see you around.
See you.